Welcome back. My name is Satyajeet Sahu and we are live from Byjus studio. So we are in middle of monsoon series. Okay, in monsoon series we are covering important topics of GATE and we are solving numericals pertaining to that particular topic. This particular week in civil engineering we are studying geotechnical engineering. Okay, and topic for today is what? Your active earth pressure in cohesionless soils. Okay, so let us first go into our this week's schedule. If you remember, this week we have geotech, as I told, we have geotech, and we'll be covering these topics every day at 6 p.m. Okay, so first of all, yesterday we completed what? Permeability in layered soil. Okay, today is 19th of July, so today and tomorrow we'll be covering active earth pressure. Okay, so today and tomorrow we'll be covering what? Active earth pressure, and we'll be seeing today cohesionless soil and tomorrow we'll see cohesive soil. Two important topics. Okay, then we'll be going into bearing capacity of soil, then pile foundation, and at end index properties. So let us first welcome who all are attending the class. Okay, let me just see in the comment section. Okay, so those who are live into the lecture, they can just see and write down hi so that I can welcome them to the class. Okay, so Juhi, Bijit, Ankur and Vipul. So they have written good evening. So welcome everyone. Okay, so let us start the class without any further delay. So active earth pressure. Okay, now earth pressure, who is experiencing the earth pressure? That we'll see, but before that a short introduction about myself. My name is Satyajeet Sahu. I have done my BTech and MTech from IIT Kharagpur. I have been selected into many of the PSUs through GATE. Okay, and then I have worked as design manager in Delhi Metro Rail Corporation for a period of 2 years. I have also got experience of more than 10 years in the field of GATE and ESE, and I teach all the civil engineering subjects and the general studies. Okay, so I will just request our technical team to just once refresh the page because I am not able to see the comments here. Okay, so let us start the class, and after some time the comments will also be visible. Okay, so active earth pressure. So this is what? This is a retaining wall. This is what? This is a retaining. So welcome Diya Ranjan, Rasmita and Surbhi and Vivek Parasar. Okay, so this is a retaining wall. This is what? A retaining wall. Okay, the comments are not visible. Okay, great. So this is a retaining wall. Okay, now retaining wall retains what? It retains soil. Okay, the retaining walls retains what? Soil. Okay, and this soil is known as what? This soil is known as the backfill. This soil is known as what? The backfill soil. We call this as what? The backfill soil. Now this particular soil will exert certain pressure on this retaining wall. Okay, and due to that pressure there will be some force. Okay, so that pressure is known as what? Earth pressure. That is known as what? Earth pressure. Now when we call that as your active earth pressure, okay, good evening Prithvi. When we call that as active earth pressure, we call that as active earth pressure when the soil is moving away from the, when the wall is moving away from the soil. So in this case, the pressure exerted on the wall by the soil, we'll call that as what? Active earth pressure. Okay, active earth pressure. Now, this active earth pressure, it depends on three things. First, it depends on the vertical stress, the effective vertical stress. Okay, it depends on what? The effective vertical stress. Welcome Mukul. Effective vertical stress. Second, it depends on what? Second, it depends on your phi, the angle of internal friction. It depends on angle of internal friction. Welcome Rahul. Okay. Welcome Sri Sai Pranav. Okay. Angle of internal friction. And the last thing which depends on what? It depends on the cohesion. It depends on what? Cohesion. So suppose you are seeing at a particular depth. You are seeing at a particular depth. Okay. Suppose depth Z you are seeing. Suppose depth Z you are seeing it. Okay. So at depth Z what will happen? There will be some vertical stress, right? There will be some vertical stress. The direction will be what? Downward. Okay. At this depth Z, there will be some vertical stress. The direction will be downward. Suppose sigma B, right? So if I am interested in finding out the active earth pressure here, means what? The horizontal stress. Because the active earth pressure is what? It is horizontal in direction because it is exerted by the soil on the wall, right? So this horizontal stress, or I can say this is the active earth pressure. I'll call this as what? Active earth pressure. Good evening, Saurabh Sri. Active earth pressure. So this will be equal to, remember the equation, Ka into the vertical stress minus 2C root Ka. Yes. So this is how you find out the active earth pressure at a depth Z. It is simply, I'll write down again, the vertical stress into Ka minus 2C root Ka. Okay. Now what are these terms? See, vertical stress we saw. Sigma B is what? A vertical stress which we saw, right? Now, next thing is what? Your Ka. Ka is the coefficient of active earth pressure. It is what? The coefficient of active earth pressure. Okay? Active earth pressure. Now this depends on the angle of internal friction. It depends on what? The angle of internal friction. We'll call this as what? 1 minus sine phi divided by 1 plus sine phi. So this is what? Ka. And the last one is C for cohesion. C for what? Cohesion. Okay. So as I told, it depends on three things, right? You can see from the equation depends on three things. One is what? The angle of internal friction. It depends on the cohesion. It also depends on the vertical stress. It depends on three things. Okay. Now, today we are seeing what? Cohesionless. We are seeing today cohesionless soil. So when I say cohesionless soil, that means what? Your C is 0. Your C is 0. If C is 0, in this particular equation, this term will become 0. So I can say the equation becomes what? This. So it is very simple, right? It is very simple. The active earth pressure at a particular depth will be what? Ka times into the vertical stress. It is Ka times into the vertical stress. Very easy, right? Now you can see this unit will be what? Kilonewton per meter square. Because Ka will have no unit and stress should have unit of kilonewton per meter square. So the vertical stress is kilonewton per meter square. So horizontal stress, or I can say active earth pressure, will also be in kilonewton per meter square. Now, coming to some business end. Yes, coming to some business end. Now you might have seen that when you're finding this active earth pressure and then the distribution, lot of formulas are there and you get confused. So our key will be how to avoid those formulas. How to avoid those formulas and solve the questions without much formula. For example, I will directly jump into the numerical. Suppose this is a retaining wall of height 6 meter. Okay, I am giving the phi as 30 degree. I am giving the phi as 30 degree. Okay, and I am saying that the gamma is 18 kilonewton per meter cube. The gamma of the soil is what? 18 kilonewton per meter cube. Now, first of all, if I ask you to find out the earth pressure, if I ask to find out active earth pressure, if I want to find out active earth pressure at a particular depth, you can easily find. Suppose I ask you, find out the active earth pressure at number 1, 2 meter. Suppose at depth of 2 meter, I am asking you what is the active earth pressure at 2 meter. So suppose this depth is 2 meter. I am asking you find out the active earth pressure. Find out the active earth pressure. So this active earth pressure formula was what? It was simply K into sigma V, right? Now K will be what? How much is K? Can anybody find out? Can anybody find out what is the Ka value? Please mention in the comment section. What is the Ka value? Please mention in the comment section. Please find out Ka. What is Ka? Find out. What is the value of Ka? Please find out. 1 minus sine 30 by 1 plus sine 30. It is 1 by 3. Okay. Very straightforward. Okay. See, initially we are starting with the easy things. We'll move on to difficult things. But initially, the first things it has to be easy, right? Okay. So it is 1 by 3. Now at 2 meter, okay, at 2 meter, what will be the vertical stress? That is very easy. The vertical stress will be, it is vertical effective stress. So gamma into Z. Yes, this Z is equal to 2 meters. So I can say the vertical stress will be your 18 into 2, that is giving me how much? 36 kilonewton per meter square. Okay. Now if I want to find out the active earth pressure at this depth, is simply Ka into the vertical stress, that is 36, giving me how much? 12 kilonewton per meter square. Similarly, if I ask you to find out the effective earth pressure at any depth, you can find out the value. Now you see, there will be different pressure acting at different heights, right? There will be different pressure acting at different heights. Now, first of all, here sigma V will be how much? At the top of the backfill, the vertical stress will be 0, right? Yes, at top of backfill. At bottom of the backfill, what will be the vertical stress? What will be the vertical stress at bottom? It will be the unit weight into 6, giving me how much? This is how much? This will be 108, right? This is 108, right? So I can say the vertical stress is 0 at the top and 108 at the bottom. Okay, so now what we will do, here it is some value. So we'll draw the distribution of earth pressure. We'll draw the distribution of earth pressure. What I'm trying to do is that I'm teaching you how to avoid all those equations. And just from distribution, you'll be able to find out total force. You see, if you draw the distribution, you see, okay, at the top we are getting 0. At the top we are getting 0. At the bottom we are getting how much? At the bottom we are getting how much? 108. You see, this 108 is what? This 108 is the vertical stress. Okay. Now at top, if I want to find out the earth pressure, that also will be 0, right? Because the earth pressure equation is what? Ka into vertical stress. If the vertical stress is 0, earth pressure also 0. What will be the earth pressure at the base? Tell me. Find out the earth pressure at the base. Find out the earth pressure at the base. Please find out the earth pressure at the base. Please find out the earth pressure at the base. Please find out the earth pressure at the base. Very easy, man. Please find out, and women also. Please find out the answer, the earth pressure at the base. Simply what? 1 by 3 into vertical stress. Yes, this is K, na? It is 36. Yes, 1 by 3 of 108, it is what? 36. So I can say that it will be 36. I'll draw it. Okay, I'll draw it. It is 36. Okay, very good. So here it is 36. Now if you join these 2 points, we'll get the distribution, right? If you join these 2 points, the top and the bottom will get the distribution. You can see it's a triangle. You can see it's a triangle, right? So if it is a triangle, and this will be also 6 meter, equal to the depth of what? The height of the wall. And you see, these are what? These are what the different stresses at different heights or depths. Yes. So if I am interested to find out, the total active earth pressure force, suppose capital PA, it is what? Total active earth pressure force. Total active earth pressure force. Now we know that if we have a stress distribution, the area will give me what? Total force, right? Right? This is the distribution. If you want to find out the force, just take the area. So this is what? A triangle. So what is the area of a triangle? Half base into height. This gives me how much? This gives me 108 kilonewton per meter. How? You see, this stress is in what? Kilonewton per meter square, and the height is in meter. So the answer I will get in what? Kilonewton per meter. So I can say this is the force. This is the force per unit length of wall. This is the force per unit length of wall. So you see, this is a very straightforward thing. It's a very straightforward thing. No need to remember any equations. There is absolutely no need to remember any equations. By just drawing the distribution correctly, you can find out the force. Just take what? Just take the area of the distribution. So if I write the steps, okay. So if I tell the steps, okay, steps. The first step is to what? To find out vertical stresses, right? Find out vertical stresses at different points. And different points, important points will be where? At the top, at the bottom, and if there is some transition in between. So different points, find out the vertical stress, right? Once you find out the vertical stress, you can find out what? You can find out the active earth pressure, simply what? Ka into the vertical stress. And this Ka will be how much? It will be 1 minus sine phi by 1 plus sine phi. 1 minus sine phi by 1 plus sine phi. Easy? Very good. Now, what is the next step? The next step will be to draw the distribution. Okay? The next step is to draw the distribution. Okay? Now, these things will help you a lot in the numerical series. Okay? Draw the distribution. See, no need to remember any formula. I'm again and again telling, okay? In the standard books and coaching material, you will see what? The formulas. And those formulas make you go crazy, na? You will feel, oh my God, I can't remember these things. But this thing, you will find it very easy. And then, total active force. Total active force will be what? Total active force will be what? Tell me. Write in the comment section. What will be the total active force? Please write in the comment section. What will be the answer? What will be total active force? What will be total active force? What will be the total active force? Please write in the comment section. Writing, you might be writing, it is long, right? Area of the distribution diagram. Yes, area of stress distribution diagram. Very good. Okay, area of stress distribution diagram. Okay. Very good. Okay, now don't okay. Okay, no, half K sigma V. Saurabh, see, don't remember like that, okay? Don't remember. Simply area of stress distribution diagram. Very good. Game over. So you see, this was, see here only soil is there. If we bring water also into picture, here only soil was there. If we bring water into the picture, suppose this is the backfill, okay? Suppose this is the backfill and it is submerged, okay? It is what? It is submerged. So if it is submerged, there will be pressure due to water also. There will be pressure due to water also. Now see, when you're finding the earth pressure, then you have to multiply what? Ka. But when you're finding the water pressure, you don't have to multiply Ka. So now there will be two types of pressures. One is due to the earth, another one will be due to the water. Now it's very easy. You see, suppose I am telling that here phi is equal to 30 degree. If phi is 30 degree, I can say Ka is equal to 1 by 3. I'll keep it 30 degree throughout so that there will be ease of calculation. And suppose I am telling your gamma saturated is equal to 20 kilonewton per meter cube. And I am saying that your gamma water is equal to 10 kilonewton per meter cube. Suppose I am giving this data. Okay. So now you see, what is the vertical stress here? First step was what? To find out the vertical stresses at important points. The vertical stress here will be 0, and suppose this is 6 meter height. The vertical stress here will be how much? It will be simply 6 into what? Gamma submerged, right? Because now it is in submerged condition. So 6 into gamma submerged will be how much? Gamma saturated minus gamma W, that is what? 10. So I can say this is 60 kilonewton per meter cube. If this is meter square. Now this is the condition, suppose. So what is the earth pressure here? The earth pressure will be equal to 0 here. And the earth pressure will be equal to how much? It will be equal to 20, right? It will be equal to 20. So if I draw the distribution, then I'll get something like this. Okay? If I draw the distribution, I'll get something like this. You see? Yes. I'll get something like this. Yes. I'll get another triangle now, right? Here it is how much? Here it is 20, here it is 6. Now see, this particular distribution is what? It is the earth pressure due to what? Soil. This is the earth pressure. Okay, say pressure due to soil, the earth pressure. This was simply what? Ka into vertical stress, and Ka was 1 by 3. Now this is due to soil, right? I can say the first distribution I am drawing is what? It is due to soil. It is the first distribution I am drawing. So this is what? Due to soil. But you have to consider the pressure due to water also, right? You have to consider the pressure due to water also. Now, the pressure due to water, okay, at the top will be how much? It will be 0, right? The pressure due to water will be 0, right? I can say the pressure due to water will be 0, right? Yes, there is no water pressure at top because there the depth of water is 0. At here, this point, bottom, it will be how much? The water pressure at any depth is what? Simply gamma W into Z. Yes. So here it will be how much? The pressure of water will be how much? Simply gamma W, that is 10 into Z, that is 6, that is becoming how much? 60. And for your kind information, don't multiply Ka in the water. The Ka has to be multiplied to the vertical stress to find out the horizontal, or I can say earth pressure, and that earth pressure is due to what? Soil. Therefore, I am multiplying Ka. But don't multiply Ka in the water pressure. That's a big mistake we students do. Never forget this. In the soil only, due to soil, you multiply Ka. Don't multiply this Ka in the water pressure. Okay? Very important point. So here I can say, if I draw the distribution, I'll draw the distribution again. Okay. So at top it is 0. Okay. Bottom I will get something like this. Okay. So I'm drawing this thing for you. Yes. I'm drawing properly. I brought a scale also, so that you also practice systematically. You also what? Practice systematically. Okay. Don't just study randomly. Okay. It's pure engineering. So you need to study systematically. And the more concepts you remember, that is better than to remember what? Only formulas. So this is 60. This is 60. So we have two pressures, right? We have one earth pressure, another one is what? Due to the water. Another one is what? Due to the water. So here what I can say, the due to soil, what is the active force? Due to soil, what is the active force? Can you find out and tell me? Due to soil, find out due to soil and due to water. Due to soil and due to water, give me the total active force. Due to soil and due to water, okay? Just take the area of the distributions and give me. Due to soil and due to water. Very straightforward. Due to soil and due to water. due to soil and due to water. Yes, due to soil it will be half, base is 20, height is 6. That is equal to 60 kilonewton per meter. And due to water, half, base is 60, height is 6. This is also 6, right? So I'll get how much? I'll get 180 kilonewton per meter. So I can say your total earth pressure will be how much? It will be equal to 240 kilonewton per meter. Easy. Now you see, this I can say the total force. If I'm interested in finding the point of application where it acts, if I'm interested in finding the point of application, how to find out? Let us see. You see in the previous diagram, there is only one stress diagram. This stress diagram is what? It is triangular in shape. We know that it's triangular, so the total force will act at the centroid. And we know that the centroid lies where? The centroid lies at h by 3 from the base, right? So this total force of how much? 108 in the first case will lie h by 3 means what? 6 by that is how much? That is equal to 2 meter. That is equal to what? 2 meter from the base. 2 meter from the base. Okay? Because straightforward it is a triangular. In the next case you see what will happen? What will happen here? Here for the first one, the soil, it is all triangular. So it will lie where? It will lie where? It will lie at, again, h by 3. So 2 meter. This is 60. And you can see that the next one is also triangular. So again h by 3. So this 180 also will act at how much? H by 3 is how much? 2 meter. So I can say this 240 kilonewton per meter is acting at a depth of 2 meter from the base, but 4 meter from the top, right? So you have to see what is written in the question. See, this is 2 meter from the base of the 2 meter from the base of the retaining wall, but from the top it is how much? 4 meter. I can say at a depth of 4 meter from the top. Okay, so you have to be very careful what they are asking in the examination. Now see, this was what? This was combined effect of your water and soil. Tell me, is there any requirement to remember any other formula apart from, just this formula that your active earth pressure is K into vertical stress? There is no need to remember any formula. You just need to know how to find out what? Your distribution diagram. If you know the distribution diagram, you can easily find out what? The forces. Okay, no formula is required, as Aptav has told. Very good, Aptav. Now let us go to the another question. What I will do, see here the soil was fully submerged. Here the soil was what? Fully submerged. Let me make it partially submerged. Okay, so water table is not at the top. Suppose it is partially submerged like this. Okay, this is partially submerged like this. Okay, so this is suppose your water table, and suppose this is your 2 meter. This is what? 2 meter. And here it is 6 meters. So the water table is at depth of 2 meter. So total depth was 6 meter like this. Now suppose the soil above it, the water table is dry, and suppose the unit weight is 18 kilonewton per meter cube. And below it, it is saturated, and suppose it is 20 kilonewton per meter cube. Okay, very good. Now, what is the gamma submerged? It will be equal to 20 minus 10, that will be equal to how much? 10. See, I am taking this gamma W as 10 here. See, nothing is given, we should take 9.81. Suppose I am mentioning here 10, suppose it's given to you for ease of calculation. If they give you 9, if they don't give you anything, they take how much? 9.81. Okay, very good. Now in this thing, if I am finding the stresses, okay, first of all, you have to find out what? The vertical stresses at important points. You can see that here we have 3 important points. One is at top, one is at bottom, another one is at the water table level. So what's the vertical stress here? Top, that is 0, right? What is the vertical stress at 2 meter depth? What is the vertical stress at 2 meter depth? Can anybody tell? What is the vertical stress at 2 meter depth? It will be simply what? Here gamma D is 18. So 18 into 2, that is how much? 36. 18 into that is 36. Unit is kilonewton per meter square. And what will be the vertical stress at the base? You see, here it is 18 and then it is submerged, that is 10. So I can say 18 into 2 plus 4 into 10, giving me how much? Your 76. It is how much? 76. So the first step is what? To find out the vertical stresses. The first step was to find out what? Vertical stresses at critical points. Very important, right? Find out the vertical stresses at critical points. Top, bottom, at that particular junction we are getting 36. If this is the case, okay, so at top, what is the earth pressure? Now I am interested in drawing the earth pressure diagram. Okay, due to earth pressure. Now tell me the earth pressure at top, bottom and at midpoint. See, I am giving phi again as 30 degree. So that Ka becomes what? Your 1 by 3. So I can say at top, the earth pressure will be 0. Okay. What will be at bottom? At the bottom, the earth pressure will be what? Simply Ka into vertical stress, that is equal to 1 divided by 3. I can say 76 divided by 3. Okay. That is how much I am getting? 25.33 I am getting. How much? I am getting here 25.33. I am getting this as 25.33. Very good. Now what will be the earth pressure at this water table? That will be simply what? 1 by 3 into 36, giving me how much? I'll get here 12. Now see, the gammas are different here. So I can say the earth pressure distribution will not be a single line. There will be change of slope. I can say here gamma is 18. So I'll get something like this. Okay, I'll get something like this. Yes, and after that there will be a reduction in the slope and I'll get something like this. Understood? The slope will change here. Why? Because the gamma is changing. So here it is 12, here it is 25.33. You can easily see that we are just finding the earth pressure by this formula. Ka into vertical stress. We found out vertical stress at critical points and I'm just multiplying what? I'm just multiplying 1 by 3. Means the Ka. No need to remember any formula. Don't remember formulas. That is, given in many of the institutes, coaching institute book. But I don't recommend that because anyhow you have to remember so many formulas. Why? To increase our burden. Now, the next thing. This was due to soil, na? This is what? Due to, I said, the earth pressure due to soil. We have to find out due to surcharge also. We have to find out, surcharge I'm telling you, due to water also. Yes. Now, I'll just give you one work. Can you find out total, not total, give me the total earth pressure force due to soil. Give me the total earth pressure force due to soil. Okay. Find out PA means earth pressure force due to soil. Find out. Let me see how many are able to find out. Due to soil, just find out the total earth pressure force. Force I am asking. Find out. Chalo. Simple what I told. Just take these two areas, right? Please find out the total earth pressure force due to the soil. Let us see how I'm able to solve it fast. Come on, solve. Just take the area of this distribution, okay? Just take the area of this distribution. Prem has found out 86.67. Very good, correct. 86.67. You can see that here we will divide it into three parts. You can see that here. Always try to divide it into what? Set of rectangles and triangles. Okay, set of rectangles and triangles. You see this is 12. This dimension will be 4. This dimension will be 2. This is also 12. You can see that this dimension will be how much? This dimension will be 25.33 minus 12. That is how much? 13.33. So we have three areas. One area, two area, and three areas. Three area is there. So can you find out the first area? Yes, the first area will be half base into height. That is 12, right? The first area will be, force will be 12 kilonewton per meter. Second one will be how much? Second one will be 48, right? You see 12 into 4. Second is rectangle. So 48 kilonewton per meter. The third one will is what? It is again a triangle. So half base into height, giving me how much? Half base. Base is 13.33. Height is 4 meter. Height is 4 meter. So 26.67 kilonewton per meter. Very easy. Yes, very easy. So you got your three areas. Okay. This total was 25.33. This total was 25.33. And this was 13.33. You see, you are not finding any, you're not remembering any formula. Simply from the diagram, you're able to solve this. Okay. So if you add all of these things, due to soil, I can say the active earth pressure you're getting is 86.67. Very good. Now due to water, see the water table is here. So you have to start taking the water pressure from here. Here the water pressure will be 0. Yes. And then here the water pressure will be how much? Gamma W into depth, that is 4. So 40. It will be how much? 40. So I can say now this is 4. So this area will be how much? This area will be half base into height, giving me how much? Half 4 into 40. That is how much? So this is the fourth area I am taking. This is the fourth area I am taking. So the fourth area is how much? It is simply 80 kilonewton per meter. So I can say due to water, and as I told, never multiply Ka with the water pressure. So here the total active force is how much? 80. So if I ask you total active earth pressure force, if I ask you total active earth pressure force, total active earth pressure force, it will be how much? Total active earth pressure force will be equal to simply how much? Tell me. It will be equal to how much? Tell me. Total active earth pressure force. Just add all these things. Just add all these things. You will get how much? You will get 80 plus 86.67. That is 166.67. Okay. So now you might be thinking, sir, it was very easy. See, we did not remember any formula. Now here I am just finding what? The total force. If I am interested in finding out the point of application, what I will do? I will take the point of application of individual forces from the base and then use a formula. Okay. What is that formula? I will tell later. First, tell me from the base, the first force, which is 12 kilonewton, from the base will act where? From the base. From the base, the first force will act at how much distance from the base? From the base, it will act at how much distance? Tell me. From the base, it will act at how much distance? From the base, it will from base here. From here, it will act at 4 and then 2 by 3, 4.67. You see, this is 4 and then this one will be how much? This one will be 1/3 of this triangle height, right? First triangle height. So first triangle height is 2. So this will be how much? This will be 2 by 3. Yes, and then 4 meter, giving me how much? 4.67. So I can say the y bar, I will call this as y bar, distance from base. Is the distance from your base. It is how much? 4.67 meter. Now, for the second force will act where? Somewhere here. The second force will act how much? The second force is acting on a rectangle. So half of that will be how much? Tell me. This will be 2 meter, right? This will be 2 meter, right? So I can say 2 meter, right? Now the third force. You see the third force is acting on a, it is acting on a triangle of height 4 meter. Yes, triangle of height 4 meter. So this will be how much? 4 by 3. How much? 4 by 3, giving me how much? 1.33 meter. The last one is also acting on a triangle, right? The last force is also acting on the triangle, and it will act at where? H by 3 or 4 by 3, that is how much? Your 1.33. Has everyone understood how we found these forces, these individual areas and their point of application from the base? Everybody is clear how we got the forces and the point of application from the base? Okay. Always draw the distribution first and divide the distribution into what? Triangles and rectangles. Triangles and rectangles. Okay. Triangles and rectangles. Now, how to find out the total force? Very easy. The point of application. I can say point of application of total force. So those are the point of application of individual forces. So point of application of total force. Point of application of total force will be equal to simple formula. What? F1 y1 bar plus F2 y2 bar plus Fn yn bar means what? Simply the summation of multiplication of force into the point of application divided by what? Divided by the summation of the forces. Or I can say total force. I can say what? Total force. Yes. Now total force we know. We have calculated. Individual forces we know. We can find out this. See, the first one was 12. It was acting at 4.67. The second one was 48. It was acting at 4 depth. And then third one was 26.67. It was acting at 1.33. The last one was how much? 80. It was acting at 1.33. Now this divided by the total force. The total force is how much? The total force value is 166.67. So what is the point of application you are getting from the base? This is from base. We are seeing from base. How much you are getting? So if you are liking this lecture, please like the video, okay? And I'll expect that you comment the summary in the comment section, that what you have understood in this particular video. 48 into 2, sorry, 48 into 2. Thank you, Prem. So how much you are getting? 1.765. Very good. You see, easily you are able to solve these questions, you see, without any formula. You see, without any formula, you were able to solve this question, right? Without any formula. So I can say that if this was the wall, right? This was the wall. The total force is how much? It is 166.67 kilonewton per meter, and it acts at a height of how much? 1.765 meter from base. You see, it is very easy. It's very easy. What you do? You find out what? You find out the stress distribution. So for soil, how you find out? Simply Ka into vertical stress, and due to water, gamma W into Z, right? Once you draw the distribution, take the area, take Y bar, and always try to divide the area distribution into rectangle and triangle, because we know in rectangle it will act at the mid depth, and in triangle it will act where? It will act at H by 3 of that particular triangle. Understood? So like this you can easily solve questions, right? So now the next thing. if we have some surcharge also, if we have some surcharge, then how the distribution will be affected? It's very easy. Suppose we have this surcharge acting like this. If we have some surcharge acting like this, okay, this is what? Q. Okay, so now we know that due to surcharge, if you don't know, I am telling, due to surcharge, the active earth pressure, due to surcharge, the active earth pressure will be into what? Ka into surcharge. Why? Because you see, if there is surcharge, due to surcharge, the vertical stress will become what? Plus Q plus Q plus Q plus Q at all depth, right? Remember this concept that, if you are placing surcharge at the ground level, the vertical stresses increase by what? Plus Q everywhere irrespective of depth. Now, if this is the vertical stress increment due to the surcharge, okay, so what is the earth pressure? The earth pressure is what? Ka into vertical stress. Ka into vertical stress, that will become what? Ka into Q. So due to surcharge, I will get what? Due to surcharge, I will get something like this. Something like this. The distribution will be what? The distribution will be a rectangle. The distribution will be a rectangle like this. The distribution will be a rectangle like this. Yes. And this will be what? This will be your 6 meter, or I can say whatever height. Suppose this is 6 meter. This is 6 meter, and this will be what? Ka into Q. Okay. And this distribution will be what? Will be constant or uniform. The earth pressure distribution due to surcharge will be constant and uniform, and the value will be simply what? Ka into Q. It will be simply equal to what? Ka into Q. So, suppose I am telling the surcharge is 45 kilonewton per meter square. And I am saying that your phi is 30 degree. Your phi is what? 30 degree. Then I can say that your Ka will be equal to 1 by 3. We have seen that. So here, what will be this value? What will be this value? Tell me. What will be this value? Tell me. This distribution value will be how much? I will just pick my scale. What is this value? Tell me. What will be this value? Tell me. 15. Very good. 15 kilonewton per meter square. Right? So if I ask you, find out the active earth. If I ask you, find out the active earth pressure force. Active earth pressure force due to surcharge. What will be the value? Tell me. If I ask you, find out the active earth pressure force due to surcharge, what will be the value? Tell me. Active earth pressure force due to surcharge, what will be the value? Please mention in the comment section. Very good. It will be, just take the area, 15 into 6, that is equal to 90 kilonewton per meter. That will be simply 90 kilonewton per meter. Very easy, very easy. Now suppose in the previous question, suppose in this previous question, I am having a surcharge also. Suppose in the previous question, I am having a surcharge also. Okay. In the previous question, I am having a surcharge also. Okay. This is the surcharge. The previous question, I am having a surcharge also. Okay. If this is the surcharge, and suppose the surcharge value is 36 kilonewton per meter square. The surcharge value is 36 kilonewton per meter square. Can you give me the total active earth pressure force now? Let us see how many are able to find. If I am just placing a surcharge now, additional surcharge, then what will be the total active earth pressure force now? Just write down. Let us see how many are able to answer this. Yes, very good, Prince. Very good. See, you have already found due to soil and due to your water. So you have to just add due to surcharge. And we know due to surcharge, I will get a uniform distribution like this. Yes. For surcharge, I will get a uniform distribution. So what I will do? I will draw the uniform distribution. I'll draw the uniform distribution like this. Okay. If I draw the uniform distribution not looking straight, let me draw it straight. Okay. Yes. So this uniform distribution, what will be this value? What will be this value? What will be this uniform value everywhere? What will be this uniform value? Simply Ka into Q. Q is 36, Ka is 1 by 3. So it will be 12. It is 12. Now this area is what? 6. This height is what? 6. So 12 into 6 will be 72. So I can say here PA is equal to 72. This is due to surcharge. This is due to what? Surcharge. So what you will do now? You will just add it. So 86.67 plus 80 plus 70, that is how much? 238.67. So this brings us to an important conclusion. What is that important conclusion? That whenever you are finding the active earth pressure, whenever you are finding what? Active earth pressure, whenever you are finding active earth pressure, find due to three things. See, if there is no water table, then pressure due to water will be 0, right? Water table has to be there. Now, always find active earth pressure due to three things. Now, due to soil, I can say the pressure will be how much? Active earth Ka into your vertical stress. Vertical stress, how to find out? We know. And then due to water, right? Due to water, it is how much? It is gamma W into Z. Z is depth from the water table. And then due to surcharge. And we know due to surcharge will get a uniform value, right? Get a uniform value is what? Ka into your surcharge Q. Right? Now draw the distributions and just take the areas. That will be the total active earth pressure force. Right? So you see, it is so simple, right? It is so simple. Okay, these things are very simple. No need to remember bulky equations, right? No need to remember any bulky equations. Okay, and if they ask you to find out at a particular depth, only the earth pressure, what you do? Due to soil you take, see, that was active force. See, if they ask you force, then what you do? Then you find out the distributions, take the area. If they ask you only pressure, just add the pressure. This plus gamma W into Z plus Ka into Q. If they ask you only earth pressure. See, there are two things. One is earth pressure, another one is what? Another one is your earth pressure force. If they ask you only earth pressure, do this. If they ask you force, then draw the distribution, take the area. So, suppose I ask you in this question, in this particular question I'm asking you, find active earth pressure. Find what? Active earth pressure. Find active earth pressure at suppose I am telling 3 meter. Can you find out the answer? Find active earth pressure at 3 meter. Let us see how many are able to solve it. Find active earth pressure in 3 meter. Let us see. Only pressure. We are not asking you force. Only pressure. Please write in the comment section after finding. First, you need to find out sigma B, the vertical stress at 3 meter. At 3 meter, the vertical stress will be how much? it will be, what was gamma D? Gamma was here 18, okay, here it was 18, and gamma submerged, I'm giving you the value, and gamma submerged was your 10, okay, these two values you might have forgotten. So gamma D is 18 and it is 10. So it will be how much? This will be 18 into 2 plus 10 into 1, because depth of 3 meter. So till 2 meter there is what? Gamma D, and after that gamma submerged. This is how much I am getting? 46 I am getting. 46 I am getting. This is what? The vertical pressure, vertical stress. Now if I am asking you the earth, active earth pressure, you have to consider three things. First one is due to soil. So due to soil, Ka, which is 1 by 3 into this vertical stress. Due to water, it will be how much? Gamma W 10 into depth from the water table. Now this 3 meter will be at what depth from the water table? This 3 meter will be at what depth from the water table? You see, 3 meter will be at what depth from the water table? It will be at 1 meter from the water table, right? It will be at 1 meter from the water table, right? So this is actually 1. Yes? Plus due to surcharge. Plus due to surcharge, it will be what? Ka into Q. Sorry, Q is 36. So I am getting here 12. So 12 plus 10, and this will be how much? I will get 46 divided by 3. 46 divided by 3 is 15.33. So somebody answered 15.33, that was due to only soil. But they have asked you total earth pressure. That means you have to take the effect of soil plus water plus surcharge. You're getting how much? You're getting a value of 22. So 37.33 kilonewton meter square. Okay. So if they ask you, very simple I will tell. Very simple I will tell. If they ask you total earth pressure, take due to soil. Yes. Take due to soil, then due to water, and then due to surcharge. Game over. And if they ask you total active earth pressure force, draw the distribution, find out the area, and that will give the total force. So easy, no need to remember any formula. No problem. No need to remember any formula. Then we'll solve another question where students face lot of difficulty. That is for two-layered soil. That is for what? Two-layered soil. That is the last thing today we'll study, and that will be the end of class today, okay? Suppose this is a 8 meter retaining wall. This is a 8 meter retaining wall, okay? And at a depth of 3.5 meter, this is suppose the depth, this is what? Suppose this is 3.5 meter and this is 4.5 meter. Total is 8 meter. So we have different phi. Suppose here phi is 30 degree, okay, and here suppose I'll find out here. Phi is 30 degree here, and phi here is 25 degree, okay. And suppose gamma here is 17 kilonewton per meter. We will start with a very simple case. We will not have complications of what? Your surcharge and all, okay. So these two data is given to us and asking you to find out the total earth pressure force. Now for this there is no surcharge, there is no water. So I'll find only due to soil only. If water and surcharge is there, we'll do it separately at a different thing. So how to solve this? First of all, find out the vertical stress. What is the vertical stress at this top? Here it is 0, right? Now at 3.5 meter, what is the vertical stress? It will be simply 3.5 into your 17, right? So how much you are getting? We'll get 3.5 into 17, that is equal to 59.5. Simply the depth is 3.5 and the gamma is 17. Now at the bottom it will be how much? It will be, you see, 3.5 into 17 plus what? 4.5 into 19, right? Because after that it is 19. So we'll get a value of, I'm getting a value of 145. I'm getting how much here? Vertical stress 145. As I told you, have to follow the steps. First find out the vertical stresses at critical points. First find out the vertical stresses at critical points. And we found out that. Okay, very good. So we found out the vertical stresses. Now how to find out the earth pressure distribution? For that, first of all, you give me the Ka1 and Ka2. So these are two soils, so I am naming it Phi1, Phi2. So Ka1 and Ka2. Now Ka1 is how much? It is simply 1 by 3 because that is your 30 degree. So if I want to find out Ka2, it will be what? 1 minus sine 25 divided by what? 1 plus sine 25. Give me this value. What is Ka2? Give me this value. Give me this value. Ka2, how much are you getting? Ka2, it is 0.405. Very good. Very good, students. Now, how to draw? Very easy. You see, remember, this is the first layer, this is the second layer. Now, the formula is what? The active earth pressure is simply vertical stress into Ka. Now, at the top, it is 0. The top, it is 0. The vertical stress is 0, so earth pressure is 0. Yes. Now, let us see for the first layer. If I am drawing for the first layer, if I am drawing the stress distribution for the first layer, then I have to take the Ka of the first layer, right? I have to take the Ka of the first layer because I am drawing the distribution of the first layer, then I will take the Ka of first layer only. So here, for the first layer, vertical stress is 59.5, okay? And your Ka is 1 by 3. So what will be the earth pressure? It will be, this earth pressure will be how much? The vertical stress into 1 by 3, right? Giving me how much? 59.5 divided by 3, I am getting 19.83. I am getting how much? 19.83. So this will be the distribution of earth pressure. You can see this will be the distribution of earth pressure. This is how much? This I can say is 3.5, and this will be how much? This will be 19.83. Understood how we found out the stress distribution in the first layer? In the first layer, just use what? Ka into vertical stress and use K of the first layer. Now when you're solving the second layer, then take Ka this one, right? Because you're considering second layer, then take Ka this one. Now at the top of first layer, the second layer, at this level, you see at this level, vertical stress is 59.5. Vertical stress is 59.5. And the Ka is 0.405 because we are seeing the second layer. So what will be the earth pressure here? The earth pressure here will be 59.5 into what? 0.405. Why? Because we are seeing the second layer. So it will be how much? 59.5 into 0.405, giving me a value of 24.1. Roughly how much? 24.1. Now at the base of the second layer, if I am seeing the base of the second layer, what will happen? If I am seeing the base of the second layer, the vertical stress is 145, and the Ka is this. So this will be how much? This will be 145 into 0.405, giving me how much? This will be 145 into 0.405, giving me a value of 58.725. How much? 58.725. So you see, drawing the distribution is so easy, and you see, you need not remember any formula. You need not remember any formula for drawing these distributions, right? You need not remember any formula for drawing this distribution. In this, we just saw that the Ka are different. So we first found out the vertical stresses, and then we draw the distribution for the first layer taking Ka1. Then we draw the distribution of second layer taking Ka2. Now, if I ask you find out the total active force, now that is very easy, right? That is very easy. Just take these two areas. So this area will be how much? Half base into height. It is what? It is a triangle. Now this is a trapezoid. So the area will be half sum of what? Parallel sides Sum of the parallel sides into the height. Height is how much? 4.5. So into 4.5. So first one, how much you are getting? First one, how much you are getting the value? How much value you are getting? First one I am getting 19.83 into 3.5 divided by 2. I am getting a value of 34.7. Roughly I can take 34.7. And second one I will get 58. You can do some approximations also. 58.725 plus 24.1 divided by 2, okay, into 4.5. I am getting a value of 186.4. You can round it up, okay. So now Prem has found correctly, others also can find out. So total pressure will be how much? The total pressure will be equal to, I can say, total active earth pressure will be equal to your 34.7 plus 186.4, and it is 221.1 kilonewton per meter. So easy, right? So easy. You see, need not remember any formula. You need not remember any formula. Just draw the distributions correctly, right? Just draw the distributions correctly and you can easily solve such questions. You can easily solve such questions if you just draw the distributions correctly. If you just draw the distributions correctly, you can easily solve the question. Now you see the total active force was coming 221.1. Now this was due to soil only. Suppose I am telling that there is water here. Suppose I am telling here is water at this level. Suppose there is water at this level, I am telling that gamma W is not given. So I can take gamma W as 9.81. Then now if I want to find out the total force, then I have to take the distribution due to water also, na? Yes? Because the distribution due to water also. So here the pressure will be 0, here will be gamma 9.81 into depth is 4.5, giving me how much? 9.81 into 4.5, I am getting a number of 44.15. 44.15, and this is 4.5. Now due to water, there will be some force that I will add. How will find out that? Simply take the area. So 4.5 into 44.15 divided by 2, half base into height, because it's a triangle. I am getting, due to water, I will get how much? 99.34. And I can add this. Okay, so 99.34 plus 221.1. Yes, I'm getting how much? 320.74. Sorry, 7, right? 74, not 74. 44. 44. Understood? You see, very easy. If they give you different layers also, water distribution is not affected. Soil distribution affected. How it got affected, we found out. Now suppose I give you surcharge also. Suppose I give you surcharge also. Let me give you surcharge also. Suppose surcharge I am giving as 10 kilonewton per meter square. I am giving surcharge as 10 kilonewton per meter square. How to get? Here there will be some difference. See, the surcharge distribution is, you see the surcharge distribution is rectangular, I can say uniform, but it depends on Ka. Now for the first layer, the Ka is 1 by 3. So here if I draw the distribution due to surcharge, this will be Ka into Q. Q is 10, Ka is 1 by 3. That is what? 1 by 3 into 10, that will give me how much? 3.33. Yes, give me how much? 3.33. And this height is how much? 3.5. So this is the surcharge, earth pressure due to surcharge distribution in the first layer. If you see the second layer, K has changed. The Ka is now how much? 0.405. So if it is 0.405, then what I will do? I will take 0.405. So Ka is 0.405 and your Q is 10. So give me how much? 4.05. You see, so easy. No need to remember any formula. No need to remember any formula. So take this area. It is how much? 3.33 into 3.5. I am getting roughly 11.7, and this area, rectangle area 4.05 into 4.5, I am getting roughly 18.2. So total due to surcharge, I can say due to surcharge, I'll get how much? Due to surcharge, I'll get 11.7 plus 18.2, I will get how much? 29.9. Okay, very good, as Prem has found. So if I'm again adding it, because I have to add due to surcharge, I'll get how much? I'll get 320.44. I'll get a value of 350.34. So total is coming how much? 350.34. So see, such a complicated question which looks complicated. You see, such a complicated question which was looking complicated, no need to remember lot of formulas. You just need to know how to draw the distribution correctly due to surcharge, due to water, due to soil, right? And these are the formulas which I told. See, tell me if you know only these three formulas, right? And you know how to draw the discharge, then you can easily, the distribution, then you can easily find out by just taking the areas, okay? I am not solving for this, but you can easily find out what? You can even find out what? The point of application by taking what? Y bar for each area and then using that what? The formula which I gave for what? Finding out the total point of application, right? So this was our class on what? How to find out the active earth pressure in cohesionless soil. I told simply find due to soil, then due to water, due to surcharge, draw the distribution, take the area. No need to what? No need to draw. Remember those hefty equations. So you might be thinking some more questions. Yes. So similarly, some more questions. If you visit our app, BYJU'S Exam Prep, okay. Visit the app BYJU'S Exam Prep, okay. So there you can go to learn with video lessons. There you can go to learn with video lessons, okay. And then in that you can go to what? Geotechnical engineering. You can go to what? Geotechnical engineering. And there you can go to earth pressure chapter, earth pressure and retaining walls chapter. And there you can see I have taken, hello Samriddhi, here you can see I have taken so many lectures. Active earth pressure 1, 2, 3, 4, 5. I have explained everything like I have explained in this lecture. And for your practice, I have solved many numericals in these 3 numerical sessions. So you can visit the app, download the app, register yourself, and you can watch these lectures and solve questions and practice. And you can see that there was no need to remember an equation, right? So thank you very much. So today we covered what? Cohesionless soil. So this cohesion was 0, right? But if the cohesion is not 0, if it is cohesive soil, things will be little different. That we will see tomorrow 6 p.m. So please come 6 p.m. okay, tomorrow. Again, a small announcement that tomorrow at 4 p.m. in the BYJU'S app, BYJU'S Exam Prep app. See, we have this official YouTube channel. Thank you, Bhaskar. So, we have these 2 things. We have this BYJU'S Exam YouTube channel, okay, and then we have our app also. So, this lecture is going on in the YouTube channel. So, tomorrow in the app I will take class and I will teach PERT. Okay, in CPM PERT, you might have heard about PERT. Okay, so PERT technique I will teach you tomorrow at 4 p.m. So that will be in the app at 4 p.m. and 6 p.m. Okay, so tomorrow 20 July we have 2 classes. 6 p.m. active earth pressure in cohesive soil, and 4 p.m. we will take on PERT. Okay, thank you very much. So see you tomorrow at 6 p.m. Okay, and at 4 p.m. in the app. Okay, in the app. PERT I will teach. So if you have liked the lecture, please like the lecture. Okay, don't forget to like the lecture. That will make me happy. Okay, and please leave the valuable comments in the comment section. that what you have learned in this particular video. Please write, summarize whatever you feel like. It is not your examination going on. See, if you summarize, you go through the lecture, go through the notes. If you summarize the lecture, it will help you only. Thank you very much. See you tomorrow at 4 p.m. in app and 6 p.m. on YouTube channel. Thank you very much.